This is the second year that I've been doing a large trial, growing potatoes in large soil bags filled with different materials and soil amendment options. This is a more diverse trial than the other one I've been doing, which was specifically looking at how relatively infertile municipal compost can be improved. With these 100 grow bags of potato plants in this second larger trial, I've been exploring different options for amending the soil that we typically find in the gardens in more controlled conditions. In addition to the possibility of using these containers filled with a soilless growing medium. Although not all the plants produced well, growing the same potato plants in so many different options for fertility and growing medium was an exploration in which I learned a lot about potatoes, soil, carbon, and fertility. These 100 grow bags were divided into 20 different options for soil amendments and growing medium, with 5 bags of each option to provide a small but reasonable sample size for this experiment. 18 of the 20 options are very similar to last year, where I'm using the same soil or growing medium, which has been topped up or fertilized again for the second season. And there were 2 new soil-based options that I added this year. A total of 12 of these 20 options are based on soil, with different forms of fertility and organic matter added. 6 of these options were filled with a non-soil-based growing medium, which is essentially growing in a more stable form of carbon. And 2 more involved active decomposition while the plants were growing, effectively building carbon while growing food. The 5 bags of each option were randomly spaced within 5 sets of 20 bags. And we planted 2 chitted seed potatoes of the same main crop variety of potatoes in all of the bags. We set up a dripper watering system for all of the bags so that watering was a lot easier, and lack of enough moisture in the 40 liters of the grow bags was not as much of an issue this year. Many of the potato plants grew really well, but there was a significant difference in the size of the potato plants early on in the season. And there was significant difference in the color of the leaves, reflecting differences in available nutrients, especially nitrogen. Potato blight hit the plants quite late in the season, late enough that we were still able to get a reasonable crop. But this would have prevented some of the stronger plants from continuing to increase the size of the buried potatoes later in the season. We harvested all of the potatoes from all of the bags on the same day, and the overall yield was about the same as last year. There was an improvement in the amount harvested for some of the options, but also a reduction in the yield for others compared to the crop last year. It is quite common to add compost or some other form of organic matter to the soil in order to feed potatoes, and I tested this in 4 different ways. 5 of these bags were topped up with a shovelful or about 5 liters of aged municipal compost, which I left mostly on the surface of the soil. The growth of these potato plants were quite poor and had leaves that were quite pale compared to the others. And the 2 plants produced a mediocre amount of potatoes for harvesting, among the worst yields of the full trial, and even worse than last year using the same compost. In 5 bags of newly sifted soil, I decided to add 2 shovelfuls of my own compost, or about 10 liters, which I mixed slightly into the surface of the soil. These plants produce better than with the other municipal compost, but still not great, with about 2 kilograms of potatoes produced with the 2 plants on average, and I would have hoped for double that. So the compost we produce ourselves isn't necessarily great, or at least this batch isn't very fertile. With the 5 bags that were filled with just soil last year, which produced a very poor crop, I decided to try using a mulch of grass clippings that I added at the beginning of the season and several times while the plants were growing. The plants growing under this sheet composting produced about the same amount of potatoes as with our own compost, and it was definitely an improved yield compared to the unamended soil that we had last year. Another set of bags were filled with soil that I had dug out from underneath the composting area last year, which would have been amended by lots of organic matter and nutrients that was brought down by the rain and the worms. These bags produced a really high yield in the first year, among the best in the trial, but the crop was significantly less this year, even after I'd added a full shovel of my own compost. So it is possible to get a decent crop of potatoes from the soil by just adding compost, but the more fertile the compost is, the better the yield is likely to be, which makes sense. And this soil can't necessarily hold on to lots of nutrients, or at least enough to support 2 crops of really hungry plants. Given that a lot of the compost that we end up using isn't necessarily fertile enough to grow a good crop of potatoes, and we might not have enough of it, I tried out several options for providing additional feeding to the potato plants. With 6 of the sets of bags of soil, we used some form of concentrated fertility that we either bought in or got from other sources. In addition to a half shovel full of the municipal compost, we added to the surface of the soil of each bag in order to boost the organic matter a bit. We added 200 grams of chicken manure pellets to each of the bags in one set, which contained a reasonable mix of nutrients, including an additional 8 grams of nitrogen. The leaves on these plants were a pale green compared to the others, and the yield was on par with our own compost and the grass clippings, and a bit less than the same crop last year using chicken manure pellets. 1 liter of complete organic fertilizer was mixed into the soil of another set of bags, which is a fertilizer that I mix myself, and likely added about 30 grams of nitrogen to each bag. And this grew reasonably healthy plants with better yields than with the chicken manure pellets, but again not as good as last year. I also noticed that these plants produced fewer potatoes that were significantly larger than what was produced from many of the other bags, which I found really interesting. With another option, we added biochar that had been charged with a liquid fertilizer and then topped it up with additional soluble fertilizer before adding the usual layer of compost. These bags produced a little bit better than the others and better than the same bags last year, producing about 3 kilograms of potatoes per bag on average. But there was also a fair amount of variability between the yield of the 5 bags, more than with most of the other options. Another fertility option involved liquid feeding the plants about 10 times during the growing season, with either a bought-in liquid fertilizer, dilute urine, or a weed tea. This regular feeding approach produced about the same amount of potatoes as the bags of biochar and the bags fertilized with complete organic fertilizer. But this involved more work with the regular feeding of the plants during the growing season compared to the other bags that only required amending at the beginning of the season. Another approach involved trying to foliar feed the plants each week, but the leaves on these plants were quite pale from the beginning of the season, so I ended up liquid feeding a few times just to try to rescue the crop. This approach produced among the worst yields of the whole trial, and a smaller amount than was produced with the same kind of foliar feeding last year. So either I'm not spraying properly or frequently enough, or this approach does not work to adequately feed plants like potatoes. For another option, I made a compost slurry of biologically active compost and decomposed wood chip, which I used to water the soil that had been topped up with the usual municipal compost. I was thinking that adding this diverse biology, in addition to some nutrients and organic matter, would help the plants in finding the nutrients that they needed. But just like last year, there was really poor growth at first, so I decided to liquid feed these plants for the second half of the season. This helped to produce a slightly better yield in the end, but the boost of biology at the beginning of the season was not enough in this context to help the plants much. With another 2 sets of bags, I decided to not add any compost or other form of organic matter. With the first option, I mixed some wood ash into the bags of freshly sifted soil at the beginning of the season. And then I liquid fed with a dilute urine about 10 times while the plants were growing, adding a total of about 2 liters of urine to each bag over the full season. This produced a decent yield, probably because of the regular supplies of nitrogen added with the urine and the boost of potassium from the wood ash at the beginning of the season, both of which are freely available sources of fertility for me. With another set of 5 bags, I only added a conventional soluble fertilizer that contained 18% nitrogen and a fair amount of potassium and phosphorus. I added most of this fertility at the beginning of the season and topped up with a bit more halfway through the growing season. And this produced a strong growth of plants and a good crop of potatoes, at least compared to all the bags of soil that had compost added. So it is possible to grow potatoes in this soil without adding any compost, though this will likely degrade the quality of the soil over many years. And I wonder if the poor quality compost that I used in the other bags had a negative impact on the growth of the plants this season, despite generally leaving this compost as a mulch on the surface of the soil. Another 6 sets of bags were filled with a carbon-based growing medium without any soil as a base. This is essentially growing in carbon, which is a more common thing to do in pots, grow bags, and containers like this, so a more appropriate medium in this context. And the overall yields were significantly better than with the bags filled with the soil that we have on this site. The 5 bags filled with the municipal compost last year and topped up with a fresh supply of the same compost this spring did better than expected and better than they did in the same bags last year. Part of this could be due to the additional year of decomposition of the compost and the half liter of complete organic fertilizer that I mixed in at the beginning of the season. There were similar results from the potato plants growing in the mushroom compost. This material from last year had shrunk quite a bit as it continued to decompose, so we added the same amount of complete organic fertilizer and then topped up the bags with a fresh supply of mushroom compost. This produced a good harvest of quality potatoes, but there was a lot of variability in the amount harvested between the bags. The bags filled with the standard potting compost that I buy in produced about the same as the other carbon-based material, with lots of good clean potatoes. But this was significantly less than the previous year with the same material, so the half liter of complete organic fertilizer that I had added wasn't enough to maintain the yields for a second season. Another set of bags were filled with a wider mix of lightweight material, including this potting compost and perlite, and these produced a better yield than the potting compost itself, even though the same amount of complete organic fertilizer had been added. The bags that were filled with my own general compost last year and then topped up with a new supply this spring did really well, better than the bags of soil with the same compost added. So at least this homemade compost is useful as a growing medium as it continues to slowly decompose. But the bags filled with the decomposed wood chip produced the highest yield of the whole trial, and much more than last year, which I was really impressed with. I think this is mostly due to the double amount of the complete organic fertilizer that I added to this material at the beginning of the season. So all of these bags filled with different types of carbon-based material seem to be able to grow a decent crop of potatoes, and the yield seems to be dependent on the amount of additional fertility added. The last two sets of bags were the most experimental and the most disappointing, but also really interesting to observe. I had filled one set of bags with straw and a bit of compost last year, and then liquid fed the growing potatoes with dilute urine for the full season, but these plants produced a very poor crop last year. By the beginning of this year, this straw had decomposed to a much smaller volume of good-looking compost, which I amended with some complete organic fertilizer and then topped up the bags with more partially decomposed straw, and then liquid fed the potatoes with dilute urine while they were growing. The crop of potatoes was very small again this year, probably due to the very small volume of growing medium that they had to grow in, but these plants were also overshadowed by the larger plants in the other bags. The same is probably true with the other set of bags that I had been experimenting with using hay and grass as both a growing medium and a source of fertility, with only a small layer of soil at the bottom of the bag. The poor yields from both of these options was quite disappointing, but I think it would still be interesting to continue this type of exploration of growing potatoes in lots of material that is still actively decomposing. There are lots of details and observations about all of this, and this trial raises a lot of questions about how to make specific approaches and options more productive, but there are also some general observations that we can make. I would assume that the differences in yield between all of these options can be broadly explained by the differences in the amount of fertility that can be held by the material in each of these bags. The sandy loam soil that we have to work with can generally hold fewer nutrients than the non-soil-based growing medium. This is perhaps an unfair comparison, as within the gardens there is usually a much larger volume of soil for the plant roots to colonize, compared to the limited volume of the bags. And if I simply wanted to grow potatoes in bags like this and wasn't interested in doing a crazy experiment like this, I would not be filling these bags with soil if I had a better medium to use. But it does show how much more the plants could produce if the nutrients were available, and this is a valuable lesson for the gardens in general. And the continued availability of these nutrients is another factor, as some of the fertility that I added at the beginning of the season may have washed out of the bottom of the bags with the rain. And some of these nutrients may have been locked up in the continuing decomposition of the organic matter that I had added, especially with the municipal compost, or perhaps even within the carbon-based growing medium itself. And I wonder how a lot of the soil-based options would have produced if I had used a much more fertile or fully decomposed compost, rather than the small amounts of municipal compost that I had added. Another big factor would be the relative proportion of the different nutrients that were available, which is something that I haven't adequately explored, and when these nutrients would be available to the growing plants during the growing season. This might explain why some of the options produce bigger potatoes but fewer of them, compared to a lot of the other plants that produce a lot more smaller potatoes, and this is something that I want to explore some more. A second season of this trial shows once again that it is possible to grow potatoes in many different types of material, with different amounts and types of compost and amendments added. But I think it really shows how much better or worse a crop of potatoes can be depending on the amount and nature of the materials that we add. and for how long of the season the materials in each of the bags can make the nutrients available for the plants. This was a long video about a big trial with so many interesting details left unexplored. Some of these things I plan to talk about more in future videos, and others will feed into other explorations and methods I use into the gardens, as well as refinements that I want to make to this trial next year. So make sure to subscribe to this channel if you like this type of video, and please check out the links to my Patreon and PayPal accounts in the video description if you want to support this channel some more and help me continue with my work in this Red Gardens project. But most importantly, thank you for watching.